Here's this week's multiple choice Monday, and the correct answer was D, in working out which of these reactions the metal species undergoes reduction. Now, it's really helpful that we know that we're looking for the metal species, and these are all transition metals, so they all have a lot of reactions where they have multiple oxidation numbers. So what it means is that I can assume pretty much all the way through all of these reactions that my oxygen is always going to be -2 and my hydrogen is always going to be +1. And I can assume that the majority of times in redox reactions, the only time I'm going to assume they are not those oxidation states is when I have, for example, oxygen O2 or hydrogen H2 gas, or if I have an unusual compound such as H2O2. But these are real outliers, so majority of time I'm using hydrogen and oxygen to work out oxidation numbers. So in A, I need to be careful that I don't just look at the charge on the ions, so I'm going from V3 plus to VO2 plus. I don't need to worry about the rest of it. The question is asking me only about the metal. And so what that tells me is that obviously vanadium is +3 oxidation state in the V3 plus ion. In the VO2 plus ion, oxygen is -2, which means that vanadium is +4. So that is being oxidized. In B, we've got what we should be familiar with, the dichromate ion, going to the chromate ion. And again, I can work out oxidation numbers. Oxygen is -2, gives me -14 in Cr2O7. The whole thing adds up to -2, and therefore I've got 2 lots of +6 for my chromium on that side, and on the other side, the chromium, we've got -8 for my oxygen. So I've actually not had a change in oxidation state. This is just an unusual thing that chromium does, where it kind of forms a different ion. It's actually still chromate 6. And in C, the same thing's happening. There's actually nothing happening to my metal oxidation number. So if I'm going from TiO2, titanium dioxide, to titanium tetrachloride, then because oxygen is -2, 2 lots of -2, -4, that is +4, it is also +4 on the other side because chlorine is going to have to be -1. Now, chlorine isn't always -1 in every compound, but with a metal, it will be because the metal will be positive, which means the chloride ion must be negative. So in the last one, I've got MnO2 and MnCl2. So actually, I could quite easily spot that because the number of chlorines is different and chlorine is only -1, that my manganese is going from +4 to +2 and is therefore being reduced. So if you want some more help with your redox half equations in particular and learning how to balance those, but also our language of redox, then I've just got a couple of spaces left this Saturday for my redox and acid-base masterclass. Practice exam style questions and stuff like that, videos, explainers, etc. on my website, and follow me on Instagram and Facebook for more tips and revision materials.